Hello and welcome to a short video on how to conduct a regression, a multiple regression using SPSS. What you'll see here is I've set the data file up appropriately. I have three predictors, multiple predictors, so multiple regression. I'm going to have more than one predictor of a single outcome. In this case, a variable I have called outcome variable. Again, normally you would try and put these give these variables names that are relevant to the study of interest rather than predictors and outcomes, but just to go through the basis of how to do this in SPSS, I've just called them predictors and outcomes. So each participant, as this is a correlational design, has a score on each of these different variables, and we're going to look at the various contributions that each of these variables make to predict this outcome. So again, I'm going to assume that you may have run through some of the assumptions to see whether it's violated any of those assumptions. We can assume that the data is normally distributed and linear, and the relationships are linear, and there's no problem with multicollinearity or any of the other specific assumptions of regression analyses. So what I'll do in this video is just go through one simple way to conduct a regression in SPSS. So the way we perform this is we'd click on Analyze, go down to Regression, and we're going to do a linear regression. So we're going to make the assumption that the relationship between these variables and the outcome is in a linear fashion. So the higher on one should be a higher or lower score on the other, or not, as opposed to having some relationship which is non-linear. So we might find that at both low and high scores there is an impact, but not at medium scores. So we make this assumption, but again, as I said, we would probably have tested this prior to this analysis. So we're going to conduct a linear multiple regression. So we click on that box, which brings up this dialog box. Now in regression it calls this dependent. This is the outcome variable, or the outcome variable of interest, and the independent variables I'm going to talk about as predictor variables of interest. There are multiple ways to input your predictor variables, but in this case I'm just going to do a standard forced entry. So I'm going to put all three predictors in to see the relative predictive benefits of including these in the regression model. So I just run through that and click on OK. That brings up this output. First of all, it tells me that I've put in three predictors, and the outcome variable is what I've called outcome, and they've just been entered. The first table gives you the model summary. This tells you how much variation is accounted for by those three variables that I've put into this equation, regression analysis. So we can see here that the adjusted R squared is 0.391, so this is about 39% of the variation adjusted for shrinkage. So a less conservative estimate is about 45% of the variation, but somewhere between 39 and 45 is our best estimate, but really this is probably the one that's most commonly used. So the adjusted R squared is 0.391, so we say that there is 39% of the variation can be accounted for, 39% of the variation in the outcome can be accounted for by these predictors. Again, we would report the specific names of these if we were writing this up. The ANOVA tests the extent to which knowing these variables is better than not knowing these variables. In other words, if I wanted to predict the outcome score, I could just say my best prediction would be, say, a mean score, and so it compares the mean score as predictor in comparison to including these three separate predictors, and it says including these three separate predictors does improve the model. It improves its predictive validity, so the model itself is significant, that these are significant. Well, by including these we can significantly improve our estimation of the outcome variable. So we would report to the extent to which our model is significant, and that's where the ANOVA table would come in. And then lastly we have our coefficients table, and this tells us the relative significance of each of our predictors and how much they impact on the outcome. So we can look first of all just down our significance column, and we'll see here that predictor 1 is really the only one of the variables which is predictive of the outcome. So actually this is the most important variable to predict the outcome. These really don't make much difference. We can look at that in terms of its values. So for every 1 point increase in the predictor, the outcome goes up 0.924, so almost 1. So there's almost for every 1 point increase in the predictor, there's a 1 point increase in the outcome. Now it looks like these ones do seem to have a higher value, but actually the important thing to look at is their standardized coefficients, which is these beta scores here. So when we look at this column, we can see that a higher score represents a stronger impact of that variable. So, which is why this one is significant. It has the score of 0.6 in comparison to these scores of negative 0.169 and negative 0.170. So these are less important in predicting the values of the outcome than this first one. Because these have been standardized, what you'll notice if you look at the values here, predictor 1 is in lots of different scores, in a different scale to these other scales. Remember, regression doesn't mind which scale it is in. This could be on a 1 to 10 scale or a 0 to 100 scale. So these scores vary more considerably, which therefore is impacted on why this score maybe is lower. These are on a 1 to 10 scale, whereas these are on a 1 to 100 scale, and so therefore these have a bigger range, and so there's perhaps bigger impact. People are more likely to have larger increases in scores in this one, and so these scores have been standardized so we can compare across them. So these are in actually standard deviation units. For every 1 standard deviation increase in this, you get a 0.6 standard deviation increase in the outcome. For every 1 standard deviation increase in this, you get a 0.16 standard deviation, etc. in these ones. So what we would report is that the predictor 1 is the significant predictor of the outcome, and these predictor 2 and 3 are not significant, and the standardized coefficient beta is 0.6, and you probably report your t-values as well in terms of reporting that statistic. So this shows you, to summarize, the model is significant, accounting for about 40% of the variation, and the best predictor of the outcome in this case is predictor 1. In your data, you would obviously be putting in the real names of those variables, but hopefully that's clarified how you run through multiple linear regression in SPSS.